Alright guys, so we're going to do this worksheet. It's only 8 problems. It's on reasonable domain and range. So it's doing domain and range like we've done before, but now we have word problems and we have to make sure it makes sense for that to be our domain or range. So who's going to read the first problem?
I got you. The surface area of a cube is the total outside area of the cube. It can be found by using the formula A equals 6s squared. Your geometry teacher asks you to construct a cube that has a side length of at least 3 inches.
Alright, so anytime you have those problems and stuff like that, like you want to circle your equation if they give you one. That's your first thing. And then you want to look for any restrictions or limits. So do we have a max or min that they're telling us?
Yeah.
Yes. What is it?
3.
Good. So it says at least 3 inches. So, and it's the side length. So is that our S or our A? The side.
S.
Good. So now, the next thing you want to do is label your domain and your range. We know domain is
X.
and range is
Y.
Awesome. So our domain is always going to be the variable inside our equation. In this case, it is what variable? S, which stood for
some odd.
side length. So above domain, I want you to write side. And for your range, what are we going to use? What does the A stand for?
Area.
Good. Alright, the next thing, is this going to be a discrete or continuous function?
Discrete.
No.
Oh,
Continuous. Now, the reason it's continuous is because your side lengths, it doesn't have to be whole numbers, as in whole inches. You could have something that's, 3.2 inches or 3.4 inches. That's okay, as long as it's bigger than the 3 inches. Now, for continuous functions, the way you write domain and range, you write them like this, with the alligators. So now, your domain, your side length, what is the minimum? What's the smallest number possible?
3.
3. And do we have the biggest number possible?
Yeah.
Does it give us a limit?
No.
No, it doesn't. So it's going to go all the way up to infinity. Now, to find our area, all we have to do is plug in these numbers here into the equation that they gave us. Well, let's start with that 3. I'm going to replace S with the 3. I'm going to do that over here. My area is going to be equal to 6 times 3 squared. What is 3 squared? 9. Good. And 6 times 9? Good. So now that I have my area, I plug that in right here because it's paired up with the 3. Now can I plug infinity in where 3 is and get an actual number like 22 or something?
No.
No. What will I get?
Infinity.
Infinity. So now I'm done with that problem. Alright, I'm going to zoom out. Who wants to read the next problem?
Got you, miss.
Alright. So, problem number 2, go ahead.
A local youth group is planning a trip to a local amusement park. They're taking their church bus, which holds up to 32 people. It will cost $25 for parking and tickets to enter the park for $22.50 per person. The equation that models the situation is CN equals 22.5N plus 25, where C represents the cost of the youth group to go to the park and represent the number of people who go on this excursion.
Awesome. So what I did here is I underlined holds up to 32 people because that is a maximum. It's one of our restrictions. I circled our equation, and then I underlined C represents cost and N represents the number of people. So now look at our equation. Which variable is on the inside of it? Not the outside, but the inside. The N. What does N stand for?
Number of people.
Number of people. So our domain is people. And our range is what?
Cost.
The cost. Good. So now, looking at people, is people a discrete or continuous? It's going to be continuous. No, discrete, because you can't have half a person. So discrete. So now, for discrete, whenever we have to write our domain or our range for discrete, we're going to list the numbers. So what is the least amount of people I can take on this trip? 32 is the most.
1.
Smaller than that.
0.
0. So I'm going to list the smaller number, and then I'm going to put some dots saying that it's going to continue all the way up to 32, because that's the most. So now I'm going to plug 0 into this equation, and then I'm going to plug 32 into that equation. So I'm going to rewrite it, showing my work. 22.5, instead of N I have 0, plus 25. What is 22.5 times 0? 0. So what number am I left with?
25.
So that's the least I have to pay. Now to find the most, what do I need to do?
Replace the 0 with the 32.
Good. Plug in 32. So when I plug in 32, they do the math, I'm going to get 745. And that's the number that goes there. And we're done with that problem. So now, number 3.
Joe has an after school job for the local sporting goods store. He makes $6.50 an hour. He never works more than 20 hours in a week. The equation is SH equals 6.5H. Can be used to model the situation, where H represents the number of hours Joe works in a week.
Good. So if H is hours, what is S of H? If you're working so many hours, what do you expect in return? Money. So H is our domain, which is hours, and money is our range. Now, hours is a form of time, so is that continuous or discrete? Continuous. And how do we write our equations, our domain and range for continuous?
Do the alligator.
We do the alligators. So what is the least amount of hours he can work?
Zero.
0. What's the most he can work? No.
20.
Yes. So I'm going to take this equation here. I'm going to plug 0 in. 6.5 times 0 is what?
0.
So I put 0 there. Now for 20, I'm going to replace it here. 6.5 times 20. And that'll give you 130. So I put that here. And then we're done. So who wants to read the next one?
Joanne decided to start a business by printing designs on t-shirts and selling them for $25 each. The printing machine cost $1,000 and the materials for each t-shirt cost $7.50. Joanne is interested in calculating the profit of her business. Profit is defined as revenue minus expenses. To get started, Joanne orders 500 t-shirts.
Good. So did they give us an equation?
Yeah.
No. So we have to come up with an equation. It says profit is, so P is equal to your revenue minus your expenses. So how much you're going to make? Well, how much are we selling the shirts for?
750.
Nope, that's how much it costs. 25.
25.
But if it's $25 that it cost, that we're going to earn, but we really spent $7.50. So what is $7.50 take away, or $25 minus $7.50? $12.50, good. So recapping that, and that's for t-shirts. All I did was I took 25 and I subtracted $7.50 from it. Because $25 is how much we're selling the shirts for, but in reality it cost $7.50 for all those t-shirt materials. Now, that's our revenue minus what's our expense? $1,000. So here's our equation. Which variable is on the inside? T, which stood for t-shirts. So that's our domain. Our range is P, which stood for profit. Now, our topic that we're talking about, that we're focusing on, is t-shirts. Can we sell half a t-shirt?
No.
No. So is this discrete or continuous? Discrete, good. So for discrete, do we list out our numbers or do we use alligators? We list them out. So what is the least amount of t-shirts?
0.
And what is the most? How many did she buy? Good. Now, if we sell 0 t-shirts, we'll go back to our equation over here. T-shirts right there. If I plug 0 in here, 1250 times 0 is 0, so that goes away. What number am I left with? What kind?
Negative.
So our profit, did she make any money?
No.
No. But now, what's the next number I need to plug in? $500. So I take 1250 times 500 minus 1,000. And if I do that, I will get 5,250. That number is going right here. So she made money now. Alright. Any questions on the front page at all? No? Alright. Number 5. Who wants to read that?
I'll read it.
Okay.
Amanda is planning on hosting a birthday party. She is planning on inviting 24 friends and doesn't know if everyone will attend. Amanda wants to provide pizza, sodas, and a goodie bag to all her friends or her guests. She found that it will cost about $9 per person.
Did they give us an equation?
No.
No, so we need to write an equation. So, what are we trying to, what would be a good variable? There's 2, but what would be a good one? That's a number. 9 times what?
P.
And what does P stand for? And what is that 9P going to give us? Like 2 words in front of that.
How much
The
cost?
The cost. So the variable inside our equation is P, which stood for person, which is our domain. And then our C is what? Cost. So again, our domain is person or people. So is that discrete or continuous? Discrete. So now, how do we do discrete? Gotta list it out. So what's the least amount of people that can go to this party? And what's the most? Good. Now, if 0 people go, how much does she have to pay? 0, because 9 times 0 is 0. Now if I plug 24 in for people, 9 times 24, what do you get?
116.
Good. And we're done with that one. So 3 more and we're done. So who wants to read to us about Landon?
Landon is taking his younger sister to the zoo. For both of them to get into the zoo is a total of $13, but his sister wants souvenirs, which cost $7 apiece. The equation that models this situation is CN equals 13 plus 7N, where C is the total cost of Landon's trip to the zoo, and N is the number of souvenirs his sister wants him to buy.
Awesome, thank you. Alright, so what is our domain? What variables inside our equation? N, which stood for what? Souvenirs, good. And what's our range? What's the other thing we're talking about? Cost. So souvenirs, is that something that's discrete or continuous? Discrete. Can't have a part of a souvenir. Alright. Since it's discrete, how do we write it out? We list it. Alright. So now, our souvenirs, what's the least amount possible? 0. And what is the most? Do they give us a limit? No. So pretend this brother is super rich. He pretty much owns the zoo. What's the most he could buy? All of them. Infinity. So from here, can I plug infinity into that equation and get an exact number? So what would I put for our range? Infinity. But now, if we don't buy any souvenirs, how much should he have to pay for everything altogether? Meaning, instead of n, I have a 0. What's 7 times 0?
0.
So what number am I left with? 13. Alright. Next problem, number 7.
Junior babysits for her neighborhood on the weekends. She is paid $12.15 an hour. Her parents don't let her work more than 11 hours per weekend. The equation of x equals 12.5x means to model the situation where x represents the number of hours when the next student is.
Good. So x is hours, so our y is money. So hours and money is our range. Now we're talking about hours, which is time. Is that discrete or continuous? Continuous. And if it's continuous, use the alligators. So now, what's the least amount of hours she can work? And what's the most? Good. So if she doesn't work at all, plug 0 into that equation, get $0. Plug 11 into that equation, multiply those two, and you will get 137.50, which goes right here. Alright, very last problem. Who is reading this one for us?
Miss Perez wants to take her out with students on a full trip to Madman. She is reserving 3 buses from the school for students to go to Madman schools. Tickets into the park cost $14.95 for each student.
Thank you. Now, do they give us an equation? No. So, what would our equation be? We have a math word right here. What does each mean? To multiply. So 1495 times what? S for what? And that's going to be equal to what? C for what? For cost. So, we said S stood for what, James? Student. And then, Elizabeth, you said C was for cost. Alright. So, can I take part of a student on a trip? No.
So it's discrete.
So it's discrete. So since it's discrete, I need to list out my numbers. Alright, so what's the least amount of students I can take? And what's the most?
90.
Good. So if I take 0 students, what's my cost?
0.
Now if I take 90, 1495 times 90, I'm going to get 1345.50. And that's going to go right in there. So that's how much it would cost for me to take 90 students. Alright, are there any questions on this at all?
No.
I would hold on to this paper. Tomorrow, when you come into class, you'll have a worksheet. Some of the problems are very similar to this. They have different numbers, though, and some are just brand new ones. You're going to work on that half the class period, and then I'll give you the answers to it. So that's what we're doing tomorrow. Don't forget, you have what for homework this week?
Edmodo.
Edmodo.